Good afternoon, everybody. Today is still Thursday, September 29th, 2022. I'm going to record a second video today, and now we're going to work into the errors concept and the try rescue concept of the Elixir syllabus here on Exercism, and then later we'll work on the RPN calculator example. So the first concept documentation is a little light, but it talks about errors. Errors happen, period. In Elixir, while people often say to let it crash, there are times when we need to rescue the function call to a known good state to fulfill a software contract. In some languages, errors are used as a method of control flow, but in Elixir, this pattern is discouraged. We can often recognize functions that maybe raise an error just by their name. Functions that raise errors are to have a exclamation point or bang at the end of their name. This is in comparison with functions that return OK value tuples or error. And you can look at these library examples. So the map module has a function called fetch. And in the normal variant, you pass it in a map and then a key that you are looking for. And if it works, you get back the value. So if you passed in an A atom, you'd get the value 1. If you pass in a B atom, you get the value error atom. However, there's also a version with exclamation point, which is, bang. This is a visual to tell you that if this function fails, it will raise an error. So in this case, it actually raises key error. Now, there's a later concept documentation in the syllabus that's going to talk about exception values and exception structs. We're not really going to get into that today. The only real core concept that we're trying to teach here is the bang. So like if you see fetch, you can expect that it'll return like an OK value tuple or an error tuple or just error in this case. If you see a bang, then the expectation is that it's going to raise an exception. And so in the next lesson, we're going to look at try rescue. So in those cases, you want to call a function that you know can potentially raise. How do you handle that? So Elixir provides a construct for rescuing from errors using try rescue. In this example, try, and then you have this do block where you can attempt to do some work, and then should you or one of the functions you call raise, it'll rescue that raise by capturing E in, and then you can, in your rescue, you can actually pattern match for actually how you want to handle it. So let's examine this construct. Line 1, the block is declared with a try. Line 2, the function call, which may error, is placed here. In this case, we're calling raise 2. In the rescue section, we pattern match on the module name of the error raised. On the left side of the arrow function, arrow symbol, E is matched to the error struct. In is a keyword. Runtime error is the error that we want to rescue. If we wanted to rescue from all errors, we could use the underscore instead of the module name, or omit the in keyword entirely. On the right side, the instructions to be executed if the error matches. So in this case, do this. Because this entirety will be evaluated as an expression, so it will return some value. Error structs. Errors, sometimes called exceptions, that you can rescue this way are structs. Rescuing errors in Elixir is done very rarely. Usually the rescued error is logged or sent to an external monitoring service and then re-raised. This means we usually don't care about the internal structure of the specific error struct. The exceptions concept, which we'll get into later, you will learn more about error structs, including how to define your own custom error. And there's one other thing I wanted to mention here too, and this was referenced in the error concept documentation. So they link to a blog post here called The Misunderstanding of Let It Crash. So if you're working in Elixir, you will hear this concept, this mantra of let it crash. And it is it is unfortunate because I feel like even myself, like we misunderstand it, we misuse it a little bit. And this article kind of goes through what it is and this author's understanding of what it means. And it's a pretty good read. Definitely check it out. I mean, the TLDR on this, although I do encourage you to read it, is that the let it crash philosophy very much comes from Erlang and the Beam, and is very much connected to the concept of processes and supervision trees, which we haven't really gone into yet. But this idea that like you will generate processes that have child processes and supervisors, and processes kind of have their own technology for retrying and making sure that like they restart. And so the let it crash philosophy definitely is highly coupled to that. And what else was I going to say? It's all highly coupled to the values of Erlang, in that, one of the high marks that we're looking for with Erlang is a fault-tolerant, like self-healing system design, and the idea that like you as a programmer can account for all of the, like, if you can account for every possible point of error is impractical. And so while if you're aware of possible errors, you may want to write paths for those to be resolved in a certain way. You also need to build your software in such a way that, like, regardless of the source of the error, the system can heal itself and restart into a safe state. Anyway, that's really high level thinking and stuff for an Exercism syllabus, but considering they talk about the term let it crash and they link to this article, I figured I'd mention it. So now we're going to work on the RPN calculator example. While working at instruments, potential spam, no, I will not answer you. While working at Instruments of Texas, I think they mean Texas Instruments. I think they're having fun there. You are tasked to work on an experimental reverse Polish notation calculator written in Elixir. Your team is having a problem with some operations, raising errors and crashing the process. You have been tasked to write a function which wraps the operation function so that errors can be handled more elegantly with idiomatic Elixir code. Okay, so we're going to copy our command to download the example locally, and then we can open that in VS Code. And let's see here, we got lib, we got our calculator, we have our test file, and we'll put our readme down here. I'll close that, and I'll collapse this. Yeah, those are just tasks 1, 2, 3. Cool. So, oh boy. Let's find here. Warn the team. Implement function calculate bang. To call the operation function with the stack as the only argument. The operation function is defined elsewhere, but you know that it can either complete successfully or raise errors. Okay, so let me... What other files are here? Okay, so given a stack and an operation, this is really obscure. Implement the function calculate to call the operation function. Oh, that's passed in. Operation function with the stack as the only argument. The operation function is defined elsewhere, but you know that it can either complete successfully or raise an error. Okay, so we just need to I assume you would just call the operation and then you'd pass in the stack. Let me run the tests. Test. Run all tests. Yeah. Task 1 finishes. Okay. This is a little awkward because it's like they basically even say it. It's like the operation function is defined elsewhere, but you know it can either complete successfully or raise an error. And this gets into like, you know, if the only way we express that a function can raise an exception is through a exclamation point in the function name, it kind of limits us when we're doing like dynamic programming, like in this case when we're accepting a function to come in. So like right away, like we don't like this test file doesn't give us a specification. Like you can see this, my inline editor is kind of like suggesting one of any to any. But there's no way to express. I don't think there's a way to express exceptions. A throwing function in TypeScript in the type annotations. I don't think so, but I know there's none in the language itself. So it makes it a little awkward to kind of trust that this operation will throw. But you know, we're gonna just follow along as the instructions say. Okay, task number 2. When doing more research, you notice that many functions use atoms and tuples to indicate their success failure. Implement the calculate function using this strategy. Okay, so this one we have to actually capture. So we're going to attempt to actually, I guess we could just return it. Operation stack, and then we need to rescue. Why can't I say rescue? And we're just going to capture everything, and we'll just say error. That might work. Run all the tests. Calculate returns a tuple. Oh. It needs to wrap the, okay. So we can just say, okay. And then the error, or not the error, the result, maybe. Run all the tests. Those look good. Okay, we're up to task 3. Pass on the message. Some of the errors contain important information that your coworkers need to have to ensure the correct operation of the system. Implement calculate verbose to pass on the error message. The error is a struct that has a message field. Okay, so given calculate verbose, oh, okay, so this is going to raise with argument error, and argument error is going to have that message. Okay, so try. So this is going to be similar to what we did before, where we attempt to call operation, giving it the stack as the first value, and then we will rescue. And instead, we'll capture E in argument error. I think that's what we were looking at here. E in runtime error. Yeah. And so that'll give you E dot message. There's a question of are they going to throw other errors? No, they don't. Okay. And I think that's it. So we can run tests once more just to validate. They all look good. We'll upload it, submit. And we'll check out what the static analyzer has to say. It looks good. And we can take a peek at the community solutions. 543 people published solutions. So that's kind of interesting because like we're pretty deep into the syllabus now. It's kind of interesting to see how many people actually got through it all. Alright, so they do anything interesting? So they just capture all of them. Say they just capture all of them and they make the assumption that Ida has a message, which is a pretty reasonable assumption in Elixir's error space. But cool. Yeah, they're the same. My mouse is very jumpy. Yeah, they all do that. Okay. Cool. So I'm pretty happy with that solution. I'll publish my iteration, and we have learned errors and try rescue. We have unlocked 5 concepts: exceptions, links, streams, task, and width. We've unlocked 5 new exercises, and our syllabus is getting filled out. Cool. We've got a bunch more unlocked. We've got 1 more hidden behind behaviors. And cool. So next time we'll probably work on width and exceptions, maybe. What is the oh yeah, they only have 1 stack underflows for exceptions. Okay. Yeah, anyway, we'll work on something next time. Until then, I want to thank you all for watching. If you have any feedback or questions, please do let me know. Other than that, hope you had a great time, and I will see you next time. Bye-bye.